discussion panel. And I believe that the next presenter will not disappoint us and will continue in the trend and will speak about the reality, data and figures. So we will continue with the factual findings and speak about systems to create to produce from cold and heat. So we have Mr. Michal Masaryk from the Slovak Technical University. He will speak about the ice accumulation system. So this will be a nice presentation.
Good morning, everyone. I am a professor at the Slovak Technical University in Bratislava, but I'm also having lectures in Brno and other countries. And I will talk about specific measures our engineering teams work on. So a short perspective, and it will also be physics and also engineering science focused on building. So I would start. On this slide, we have classic modern administrative at a building. Today, buildings are built with concrete skeleton, and it's cladded with the glass panels, and this is a catastrophe. It's a greenhouse with a minimum accumulation ability, and it's without megawatt air conditioning. It's inhabitable in summers. Me and my colleagues, we are differing about the percentage and about the scope of the problem. The problem, it's a big problem. Everybody talks about electromobility, and we have a problem here because we need to use air conditioner all summer, and it won't be better. This is a perspective on one plant of Volkswagen. This is, you can see, black building, and I went on the roof and I measured the black asphalt roof that had 70 degrees. The heat load is enormous, and usually when it's needed to deal with it, we just strengthen the air conditioning systems. The megawatts need to get outside. So what to do with it and how to avoid this? We will have a look at the cold, because this is of our interest. We have cold meters, and cold is an expensive energy commodity, meaning to use the air conditioning for the whole summer is expensive, and the performance is 2-to-1 depending on the temperatures. If electricity is expensive, like we had 2 years ago, also the use of air conditioner is expensive. The second factor, I will go a little bit backwards. How to put it back? I will just say it. The daily diagram, and we called it like, it was like a camel with two hunchbacks. As soon as we got the photovoltaic, the diagram got broken, because very often we have negative prices during the day, especially when the solar power plants are have high performance. So now the diagram is no longer like this camel. Let's have a look. if the cold can be produced, it's an expensive commodity. We create it from electricity or photovoltaic panels, and I will show you that it's also possible from waste heat, solar, or other. So I will go a little bit into research, this applied or applicable research. So waste heat, Dr. Dědeček talked about it's not important how much energy you have, but what kind of quality. And he talked about entropy. We use it as work indicator. It doesn't matter how much heat you have, but what temperature you have, or what temperature the heat has. So, you know, when it comes to waste heat, there are plenty of megawatts in summers. You usually have over 50, 60 degrees in summers, and industry, you have plenty of such heat and you don't know what to do with that. And the roofs have extraordinary high potential. So we came with an invention, and we created a cooling machine taking this waste heat and turns it into air conditioning cold. This is a typical collector, classical collectors that you buy. They are constructed for 60, 70 degrees, which is enough for summer showering. And the basis, the principle of thermosolar panels, they are great in summer, but you don't know what to do with it in summer, but they almost don't work in winter. But let's move to this issue. You can see the comparison on the slide of two systems. This classical air conditioning system, it's just a cooling machine, and the compressor has the warm and cold side, and on the cold side we have low pressure of the coolant, and on the other side high pressure of coolant. So we, you know, engineers wanted to avoid the bad compressor so that we don't use electricity. One possibility is the ejector or steam jet cooling system. So when you look at the right side, when you have a narrowed pipe and there is a medium running through it, the liquid, it's faster created there. And this, there is a negative pressure and suction created there, and this has been used for what compressor had done. So we can create a very simple cooling machine. It has 3 of these exchangers, and it's driven by solar or waste heat. This is how it looks like in reality. This is machine. This is my PhD candidate working on it, and we managed to construct a cooling machine that is driven by heat of these low temperature parameters, and still they are simple and cheap, and they are called steam jet cooling system. And previously it was actually used, but then we forgot about it. So maybe we can say that we need to dust the old knowledge, but in the meantime there was no team left in the European Union who would remember that. So we needed to read and find the old books, and we needed to convert their complicated calculations without any calculator or computer, and we could repeat it or replicate it. So this machine is a third prototype of ejector cooling system. When the heat input is 80 degrees, you can have 80 degrees in any collector, and this is the heat input for this machine. This is a short view on the science that hasn't died yet in Slovakia. These are These are the jets. And I'm a professor, so that's why I'm running before the board. So you have a supersonic circuit, and here you have what a compressor made. So I need this heat to go in this way. So the first application, we have been working on it for over 5 years. Slovak Technical University has experimental area in Trnavka. This is experimental site. We have 2 containers on which we can perform these experiments. So we tried if we are able to air condition the building and under what conditions. In order for us to be able to implement this project, we joined our colleagues with the construction technical industry. We created a specific double facade, and we can put the machine into the facade cladding, and there we can, into this outer shell, we can put this thermal panels. So then what it means is that the load for cold, it lowers, and the building is air conditioned directly behind the wall. This is the cross section of the facade part. So this is how it's being built nowadays. In the yellow part, there is a place for this machine which has to have triangle shape. The machine looks like that. When you look at it, it has triangle cage. It has 1 liquid pump and also supersonic ejector that I've been working on for 5 years and works well. This is what I will put into facade. It's very simple. There are 0 moving particles, and it's like self-moving machine that will just continue going or running whenever there is a heat. This is a drawing of, this was the drawing of the machine, and here you can see the slide of the machine that is now in existence in a laboratory just 100 meters from here. So after 5 years, it has exactly the parameters that we calculated or computed, and then the next summer is ours. So that was a very short view on the machine that can create cold from waste heat, and it's invincible, and it can be very well used in industry. And we are now trying it in a chemistry industry in Skalica and in other place. So they have lots of waste heat, and we offer them to try this machine. But let's get back to the basics of physics, to another topic. The accumulation is a big topic. We've already spoke about it. And now heat and cold, how to accumulate it. Here you see the table. C is specific heating capacity, how much of heat you need to heat the material by 1 degree. And you can see that the best is water. How to accumulate, if to accumulate heat or cold, then into water. But even better are evaporating heat, is evaporating heat. When you create 1 liter of steam out of liter of water at 200 degrees, then you have 2,500 kilograms per joule. And another interesting thing, how to accumulate cold, is ice. The ice has 333 kilojoules on a kilo. So if you create ice from water, you have great accumulated energy. It's not my invention. They already knew it from Middle Ages when they built castles. They during winter, they were mining the ice from the rivers, from the frozen rivers, and they put it into icing place within their castles, and they kept this this capacity till spring. And if I need to accumulate the energy, and the energy ends up as cold, I will use this middle age technology, and I will not use, the battery storage from China. It's expensive, and this battery has a couple of thousands of cycles, for example, 5,000. But you can store these megawatts into stupid, silly ice. This is how it looks like in industrial rendition. So you have a cooling machine, and the idea is very simple. 1 megawatt hour you can store in ice up to 11 cubic meters. And this is how you can store 1 megawatt hour. This is how the industrial rendition looks like. And the idea behind it is very simple. As the gentleman said at the beginning, talking about ecological measures, this is very clear ecological substance of a measure. So we have energy on the market, and energy is sometimes expensive, sometimes cheap. And if the energy is cheap, I will make the energy, generate the energy, and I will store it in ice. And if it's expensive, then I'm switching off the cooling compressors, and I'm delivering or providing for the building through the stored energy and in ice. So we can equip the building with very simple physical solutions in order to have more ecological operations. So you can see the combination of ice accumulator with the cooling circuit. So you have chiller and fan coil, and if I put in the ice storage, then whenever the price is very high, I can just switch off the chiller, and it can be the energy can be provided from this accumulator. And how does it look in practice? This is again first machine. We are building 5 cubic meter machines. Again, here at the Slovak Technical University, even a simple scheme requires work. We did it, and we will have the first deployment in one factory, because this is because even the most stupid manager will understand that you will earn this and this amount of money through using this machine. And we see the huge evaporation potential of water, and we talked about how to cool or how to produce cold, because the machines are expensive and even it produces carbon footprint. I can again use the old methods to use evaporating heat. These little showers that are at the squares, you feel great, and you think it's because the water is cold, but it's not because the water is cold, but because it evaporates. Here it's water. You see the water evaporating. When you pour it out, it evaporates. And in order for the water to evaporate, it needs heat. It will take it from the environment. It cools the outdoor or external air, and it evaporates. And if you start to use such water on the roofs, if you use the water on the roofs, you will not waste the water. The water will evaporate, and you will not need to use air conditioner. When it comes to investment, you just need some pipes, you will buy a pump, and you're just watering your green roof. And this has already been known for 1,000 years. And the next one, to close it up, how to create the heat, it's to use Fresnel solar collectors. Many people already know it. It can be done. This is Fresnel collector, meaning the sunlight is concentrated into absorber here. This is how you can produce 300 degree temperatures, and you don't need to waste gas to create it. And this is how it ended up on the garage area at the university. This is where we have the mirrors, the tracking mirrors or adjustable mirrors, and this is where it's concentrated. Because, well, it's not as simple, because the sunlight or the sun is always at a different position every day, and you need to turn or adjust the mirrors accordingly, either through algorithm or manually, as it's needed. It's not such a problem. It's not parabolic, but still it needs some effort. So this was also another thing that we entertained ourselves with, and it's ready. So this is our colleagues playing, and this is how it looked like with the mirrors. And that's it. Thank you very much for your attention. That was one view into our micro world. You really did not disappoint. A control question. Do you also have like mature education? Can I just send an application to your university? Yeah, you can attend our lecture at any time because they are public. What I really saw in you is a good winemaker, because I haven't met a good winemaker who wouldn't be optimistic with a good solution always. And even you have a name, Masaryk, yeah? So hats off and a huge applause for you. Thank you very much. I'm looking forward very much